Hello. Originally, I didn't want to record any videos because reviewing, graphing, and analyzing functions is something that you spend a lot of time in algebra and pre-calculus class, and there is no way I can review all that in a short video. However, I do want you to read the following instructions carefully because um, they are very clear regarding what you are encouraged and what you are not encouraged to do when it comes to simple algebraic tasks such as graphing and analyzing functions. And instructions say that you are encouraged to use technology to perform all pre-calculus tasks. This is something I do allow students to do in calculus classes, and that serves multiple purposes. For example, if you are a great student that knows how to do all this by hand, learning how to do all the same things with technology will allow you to go to the next level. Similarly, if you are not a great student and you struggle a bit with doing all these pre-calculus tasks by hand, learning how to do it with technology will give you a chance to go to the next level. This is why I encourage students to learn and use technology as much as possible, but only for pre-calculus tasks. In this case, we're going to practice Desmos, which is a great tool for graphing anything, such as functions or equations in general. And in the first homework, if you're not going to be using technology, it may take you a while of going back and forward with your notes from pre-calculus class. So I do want you to use technology, and let me show you how I would have done this homework if I was a student in this class in the most efficient way. I'm not even going to use pen and paper, which is something I don't support necessarily, but in this case, I just don't have a digital pen and paper. So I'm just going to be using my computer and technology to answer all these questions. And the first question is to find the domain and range of a given function. And to find the domain and range of a function, so one thing we can do with a function when we are given a function is we can graph it immediately. So the first thing I'm going to do here is I'm going to graph this function, and you may know right away the answer to the first question, but still, it doesn't hurt to see what the graph of this function looks like. And domain is all the x values, so for which the function is defined. So looking at the graph of this function, we clearly see that this function is defined for all the x values. Analytically, you can conclude the same thing by remembering that absolute value function doesn't have any restrictions on the input. So domain is all real numbers. On the other hand, the range is all the y values which the function produces. In this case, we can clearly see that the function produces all the values below and at -3. So in interval notation, it will be from -infinity to -3, and -3 is included, so I put it in a bracket. Now, answering this question analytically may take a minute, because to answer this question, you have to make an argument that says something like, this is always positive, therefore this is always negative, and therefore when you subtract -3 for something that is always negative, you always get a number that is less than -3. So again, making that argument may not be a crystal clear, may not have a crystal clear expression in your mind. So using technology is a great substitute for that. And of course, we got this question right. So let's move on to the next question. You have to be careful not to go to the next assignment. So let's just click on continue. find domain and range of this function. Let's just type this function. All right, so this function is interesting. So what's going on with this function? It looks weird. However, if you just zoom in and change the x values, let's say from negative 100 to positive 100, you'll be able to see the graph of this function better, right? So this is what it looks like, and it looks like the domain of this function is defined for all the x values. So the domain of this function is all real numbers. Again, so it's going to be from negative infinity to positive infinity. And the range, you can see that this function has a horizontal asymptote at 0, right? So this is a horizontal asymptote. So that means the function itself is always above that, but it also, while it's above 0, it's also below this number right over here. So what is this number right here? So do you see how we can estimate this number as 0.14 something, right? We know approximately what it is, but the software isn't going to be happy with that answer. So we need to figure out this answer exactly. And based on this picture, how can we find this value? Well, it looks like it's the y-intercept. So to find the y-intercept, we just simply plug in 0. And when you plug in 0, Desmos does give you like a rounded number, but we can also write it as a fraction. That's one way. On the other hand, we can also just, plug in 0 by removing this term from the definition of a function. So one way or another, the answer is 964. So the domain is from 0 to 9 over 64. 0 is not included, 9 over 64 is included. So we answered the question. Again, nice and easy, no pen and paper, just technology. I'm not even interested in reading their solution because it's just algebra. Let's continue, find the domain and range, another domain and range, but all of these problems are pretty much the same. So rarely you'll get into a problem that gives you problems, right? So let's see, this one, where's the function? So the function looks like it's a reciprocal of a radical, so it looks like it's approaching to 0, it's approaching the x-axis from below but never touches it, so it seems like the range will be all the values below 0, so we can answer that right away. So it's going to be from negative infinity to 0. 0 is not included. And the domain of this function, it looks like this function also has a vertical asymptote. So x equals some number. Not sure what that number is. Why is it? It's so weird. That's weird. Let's see. Let's add a slider for a, and now we can use that slider to define x, right? So depending on some value of x, so we have to exclude some value of x. So we have to pick this value of x that is a vertical asymptote to this graph. And to answer this question, how do we actually find this value precisely, right? It's somewhere here, but it's definitely not negative. It's not just negative 1/2. So we notice that the vertical asymptotes usually happen when the denominator is equal to 0. So in this case, when you set denominator equal to 0, such as you set 6x plus 7 equal to 0, you are going to get exactly the answer to your question, right? So this is This is it, right? This is your vertical asymptote. However, it does look like this is an approximation. But at this point, solving this equation analytically isn't that big of a deal, right? So we see how 6x is equal to -7, therefore x is equal to -7 over 6, which is exactly what we see over here, right? So the right answer is -7 over 6, and it goes all the way to infinity. So we got this answer right. And it's not included because function is not defined at that far. And of course we got the answer right. Find the domain and range, and it's a roller coaster here. Some problems are easier than others, but this is clearly some sort of parabola. So we shouldn't have any issues with identifying the domain and the range of this parabola. The domain is all real numbers. And the range, here you can clearly see that the range is from 0 all the way to infinity. And we finished this homework. So there are many other homeworks. So this homework, if you're not using technology, could be really, really annoying. So I'm going to launch it in a new tab to give myself more room to work with here, and determine the intervals where the function is decreasing. Well, let's type the equation of the function, and let's see where it's decreasing and where it's increasing. This function is a parabola, and it's decreasing. It's decreasing on the interval from -infinity to -5. And usually we don't include the boundary, but I'm trying to read these instructions here so we don't make a mistake and so we don't have to redo this problem. Let's just go with that. Let's not include it. Yep, that's right. So again, spending time reading all these instructions will take you into some rabbit hole from which you may not recover. And we need you to get to this homework as fast as possible. In this case, the graph is already given, so we don't even have to worry too much about graphing it in Desmos. We just really need to focus on the task. And the task is determine where the function is increasing. Well, clearly it's increasing starting somewhere here, right? So that's kind of all there is to do. Let's continue. Determine the interval where the function shown below is increasing and decreasing. Well, this function is always decreasing, so it's nowhere increasing, so I'm going to put an empty set when I find it here. This is an empty set, and this function is always increasing, so we're going to put the -infinity to infinity. Did I say increasing? Always decreasing. -infinity to infinity right here. And of course we got it right. Same thing, graph this function. There is no need to struggle and try to imagine this function without, like, when you don't have technology, like, how do you answer this question? Well, you may have to do like a derivative test or something, but no need for that. Just graph it using Desmos and answer the question from Desmos. So this function looks like it's decreasing. The vertex is at 0, 1, so it's decreasing starting at 0 and all the way to infinity. And we finished that assignment. So let's go to the next one. This one was, again, maybe I should identify the topics of each one of them. So let's go to the next one. Next one is about finding zeros and intercepts of a function. Let's take a look. Find the y-intercept. Again, I'm not even going to read the task. As soon as I see function, I'm just going to open Desmos and graph it, and then I'll read the task. So negative 6x minus 5. So this is my function. Now let's read the problem. It says find the y-intercept. Okay, so we may need to recall what a y-intercept is. Y-intercept is a value, it's the y value when the x is equal to 0. So simply replace x with 0, and whatever y is, that's your y-intercept. It's that. It was supposed to be that easy. Interesting. The y-intercept of f of x, typed it correctly. Interesting. So, should have read the instructions. Enter the answer as an ordered pair. As an ordered pair means we have to enter the x-coordinate, which is 0, and we have to enter the y-coordinate, which is negative 0.2. And now we got it right. Let's find all the zeros. So the zeros is a fancy word for the x-intercept, and the x-intercept, it's similar to the y-intercept, except now we set the y equal to 0. So in this case, setting y equal to 0 means we let the left-hand side equal to 0. However, we can set that equal to 0 by typing this equation. So it will solve it for you, and it will point to this point on the graph. But well, there's no but. Just what is the x value of this point? It's 5.33333. What is 5.333? It's 5 and 1 third. What is 5 and 1 third? It's 16 thirds. So that's the answer. So again, visually we could have identified this point on the graph by looking at the intersection of the graph and the x-axis. However, to answer the question, we may have to put some effort into figuring out the exact value. Sometimes it is impossible, but a lot of times it is quite possible. So we are capable of doing it. Now, this one is a radical function. And let's see, we need more and more room now on the right side. And where's the graph of this function? What happened to it? Where'd it go? Oh, there it is, right? So, and what are we doing with this graph? It looks like an interesting graph, right? So it looks like it's entirely in the third quadrant. It's always, it's an increasing function. And if we zoom out, that's what it looks like, right? But it seems like it never touches neither the x nor the y-axis. So if the question is find all the zeros of this function, we can clearly see that this function doesn't have any zeros visually. However, looking at the equation of this function, you don't know right away whether it does or does not have zeros. So figuring out zeros, it's a matter of solving this equation, which is a process that at this level we don't want to engage. So again, visually there are no intercepts, so I'm going to answer this question with an empty set, and that's right. Next question, find the y-intercept. The y-intercept is the output when the x is equal to 0, so it's, in other words, it's where the graph intersects the y-axis. And I'm not going to make the same mistake twice. The origin is the right answer. Let's continue. Oh, we're done. So if you do all the problems right on the first try, which is what I encourage you to do, then homework is pretty straightforward. Nothing really to worry about. All right, so let's move on to the next one. Describe the symmetry properties of a function. This one can be annoying either way, whether you use the technology or not. So let's see what we got here. Okay, so what are we talking about when we're talking about symmetries? So there are several types of symmetry. There's a symmetry with respect to the axis. When there is a symmetry with respect to the y-axis, a function called even. When there is a symmetry with respect to the x-axis, then we don't even have a function because it wouldn't pass the vertical line test. But such symmetry does exist in equations, such as equations of ellipses, hyperbolas, circles, which are not functions. There's also a symmetry with respect to the origin, which again you can visually should be able to identify all those symmetries. So looking at this graph, don't see any symmetries, neither with respect to the origin nor the y-axis. So none of the above. Same thing, right? So is this function odd or even? Even means it will be symmetric with respect to the y-axis. Odd means it will be symmetric with respect to the origin. So whatever happens in quadrant 1 will be kind of mirrored in quadrant 3, and similarly quadrant 2 will be mirrored in quadrant 4 and vice versa. In this case, nothing going on here. Again, visually, it just doesn't look like it has a symmetry, so the answer is no. This one, they don't give us the graph, but again, in this class, you can graph it yourself. It's really not a big deal. So 3x to the power 3x to the power 7 minus 2. Looking at this, ooh, that's a pretty graph. It's like this little bump. Otherwise, it seemed like just a hyperbola, but this bump kind of ruins everything, so it doesn't look like it's symmetric at all. So, nope. And, ooh, that's beautiful. This is actually pretty because of symmetry, right? But is it symmetric? So it's clearly symmetric with respect to the y-axis. So if you fold it, this line will perfectly overlap or overlay this line. The symmetry with respect to the origin, it's harder to check, but well, we also can check symmetry with respect to the x-axis. If you fold it over the x-axis, it will also perfectly overlay itself. And the origin symmetry, kind of the easiest way to check is to draw a line from one point to the origin, and it should hit the other point at exactly the same distance as the original point is from the origin on the same line. So looking at this, it looks like it does have all the symmetries. So this is a beautiful graph. And we're done. Again, I'm flying through this homework, and when you fly through this homework, you get less homework to do, so I don't see all the variety of questions, but whatever questions you will get to see, I'm pretty sure they will be similar to the ones that I'm covering. And next one. Ooh, next one's going to be fun. Why? Because it's fun to graph functions when you're allowed to use technology to graph functions. So let's see what it looks like. Oh, they actually... Okay, so they don't let us use Desmos. We don't need to use Desmos. We just have to play with this curve. -9, -8. Yes, this is actually pretty fun task. -1, 4. 3, -9. 7, 7. So let me just spread them out. -1, 4. 3, -9. 7, 7. And 8, -6. That's such a cool. Oh, another one. How could you not love this homework? -4, 3, -1, 0, 6, -6, 7, 5. Fun. Oh, more. It just doesn't stop, huh? Negatives. Ooh. Stay focused, right? -7, -9, 1, 2. Let's start from the right. 7, -1, 4, -8, 7 going up, 3, -2, and 1, 2. It just doesn't end, huh? -8, 7. Well, now I'm getting bored at this point, so it's just the same thing over and over. We don't even get to practice the Desmos tool here. It's called beating a dead horse. So 3, -9, and 8, -2. And we are done. Let's try the next homework. Ooh, the next homework is the next lesson. So for this one, I will make a different video. So if you have any questions, please do not hesitate to reach out. The intention for assigning this homework was for you to practice your technology skills and not to get frustrated with the homework or the software or anything in this class. So like I said before, if you have any questions, please do not hesitate to reach out.